In the following video, we are going to demonstrate how SQL join multiple tables together, including self-join. We will also deep dive on window functions. Now let's look at another interview example from Netflix. The question is that there are three tables which has many-to-many relationship. Those three tables are order table with order ID, order date, item table with item ID and name, order item table, and with order ID and item ID to find all the customers who purchase both Kindle and Alexa. Find the item in the first purchase from a customer and duplicate the rows from the order table. So the first two questions mentioned about customer, but you can see that the three tables is given. There is no customer information at all. So it's not uncommon that the interviewer will left the required information out of the question and let you to figure that out. So if you encounter this situation, don't feel surprised because it's just a way that the interviewer would like to test your comprehension to the problem and also your communication skills. So you will say, yeah, if I want to find the customer information, we need the customer information in those three tables. The customer information it should not be in item or order item. It should be in the order table because the customer who placed the order. So this is the problem and try to get all the information you need. Then the second one is to visualize the relationship between those tables. So now we have an orders table, which has three columns: customer ID, order ID, then order date. Then we have items, order item table, which has order ID and item ID. And then we have items table, which has item ID and the name. Okay, so give an example. Maybe we have one record, which is the customer one who placed order one on day one. And the order one actually has two items, item one and item two. Then items has the name. So item one is called Kindle. Item two is called Alexa. Okay. So in this case, if we know we can join order table and the order items with the order ID. Then we joined order item and the items with the item ID. So if we join this together, we know that this one is associated with this two, and this one is associated with this one. So we come out, we know that C1 is placed order one, day one, and the order one has two items, which are Kindle and Alexa. So first, visualize the question. So if you got this right, then you should be able to answer the questions. Now go to the coding part. So I create a toy example with simple numbers, with some simple data, but even for a larger data set, the query should remain the same. So here, customer one have order one and order two on this day, and the customer three has one order, etc. And the customer one come back on the actually here. Customer five also have a place order number 5 here, and the customer 5 actually come back on the second day, place another order, which is order 6, and the customer one come back on 2 days later. 2 days later on the third purchase, place order 7, and the customer 3 also comes back. Then we have a new customer, customer 6, which comes on the 5th that we haven't seen before. He he or she place order number 9. So this is the order table. And then here tells us that order 1 has 2 items, item 1 and item 2. Item 2 also has 2 items, item 2 and item 3, etc. Sometimes they have 2 items, and sometimes they only have 1 item. For example, here 7, 8, 9 only have 1 item. They are all purchased item 3. Then lastly, we have an item table which tell us item 1 actually is Kindle, item 2 is Alexa, and item 3 is the subscription. Okay, so this is the example. We want to find out all the customers who purchase both Kindle and Alexa. So first, let's just did what we just say. From orders. Okay, so this is nothing but just like what we just say. We link the order ID together. We link order and the order item together by order ID, and we link the order item and the item together by item ID. It's just exactly doing that. Okay, and then we got what it's clear that customer 1 they purchase Kindle and Alexa. Customer 2 purchase Kindle and subscription. Customer 3 purchase Alexa and subscription, etc. Okay, so with this in mind, then we want to find the customer. They only purchase Kindle, so we will say the name equals Kindle. So those are the customers who purchase Kindle. So we can give it a name like called Kindle. Okay. Do the same for Alexa. Then we have a K and A that we want to select. Okay, then we should get the customer we want. Yeah, this is C1, C4, and the C5. So sometimes you want to have a distinct here, just in case that we have a duplicated row. In this case, we don't have, but sometimes it can happen. So more general, you should have a distinct here. So this is one way of solve the problem. So those are the customers who purchase both Kindle and Alexa. There is another way use self-joint. What self-joint does is this. You have a table like row 1, row 2, row 3. When you do a self-join, you actually add like row 1, row 2, row 3, row 1, row 2, row 3, row 1, row 2, row 3, and then repeat those. So just make all the combination. So instead, if you have n rows on this table, you do a self-join, you get n square rows after self-join. Okay. Then let's do another way to do this is do self-join. It can be a little bit tricky, but let's copy this over. Let's go back to this. The reason I want to do the self-join is that if I do a self-join, then those are the items that the purchase. So if I can get that row here is, for example, this is Kindle, and this is Alexa. I know this user must be purchased both Kindle and Alexa, or if this is Alexa and this is Kindle, then this user purchased both Alexa and Kindle. This is why we also can use self-join to solve the problem. So for self-join, we select. So now we have we kind of do a duplication or do a cross products on the order table. Then I need to join the O1 to because O1 only has order ID, I want to get the item, like how I just did. So I want to join the order item. And do the same thing for the second column. For the duplicate. Then we need to, again, map the names to get Alexa and Kindle. Do the same thing. Give it a name on the second table. Then we just say that, then I want name equals Kindle, and I2 name equals this, or the other way around. Yeah, so this is going to give us the same answer. So the advantage of this is that you don't really need to scan the table twice like the first solution. The first solution is very straightforward and intuitive, that you just get all the Kindle user, you get the Alexa user, and you join them to get the intersection. The second one looks like more complicated, like they use the table multiple times. Every table was used twice, but sometimes SQL is very good at doing the join, especially if you set the primary key right. So this query can be more efficient, even looks like it joined multiple tables. Okay. So this is about the first question. Get the users, they get the both Kindle and Alexa. The second question is find the item in the first purchase for customer. In the previous example, we show the first purchase, you can do a sort by and select the top one. But when you do an order by, it's kind of sort by the whole table. Now we want to find the first purchase for each customer. So sort on the table, whole table is not going to give you the solution for the first purchase for every customer. So then we need to do something different. So then here I would like to introduce a function called row num. Row num, this function doesn't take any parameters, and you can do a partition, and you can do an order by. So this is the syntax for row num. You partition. Okay, but let's see how it works. Like I want to look at the purchase for every customer, so I want to partition by every customer ID. And then because we want to look at the first order, so let's order it by date. Let's copy this. Actually, we don't need this. Let's look at the orders first, because those customer ID and the day ID are in orders. So this is how, actually let's start first. This is how the row numbers works. It's very handy. Basically, it's an order, it's a sold item, but it looks at partition is look at the customer ID. So every different customer ID, the counter restart. So they start with customer 1 and 1, 2, customer 2, 1, and when you jump to customer 3, you have a 1, 2, and etc. So this is really handy. And we know 1, when it is 1, then it's the first order. So we can say this 1. And we select this table, we have a customer, but the output, we need a customer ID and the item ID. So let's join T0, join with the order item table, like we already say T0, order ID equals What order ID? So it's going to give us item. So we just want the custom ID from the T0. Then we want the item ID from the order item table. Then we know here we want only the first purchase. This should work. So yeah, so but let's do a distinct. Actually, it's distinct already. So which says that the first order of C1, which has 2 items. C2 has 2 items, 1 and 3. 3 has 2 items. Number 4, 2 items. C5 and C5, they are all first items. Remember, C5 and C3 comes back. So C3 first buy 2 items and then come back with another one, but the second purchase doesn't count. CY also comes back, purchase another item, but we only list the first one. So this is the solution. Again, use the row number to get the row number to get the order and sort it by order day to see which one comes first. We use this number to pick up first order, and when we have the order item, it's just a simple join like we did earlier. Let's answer the second question. So the question is, delete duplicate rows from the order table. For this question, we are going to tackle this question by multiple steps. First, we add one temp column to the table. We are going to use the row number again. And then we first add one, and then we set num to be the row number output. Then we know we want to choose the first one. The others are all duplications. So we have delete duplications. And then we drop the temp column. That's how we are going to proceed. So we first select star from the order table to see how it goes. First, it doesn't have duplications. Let's artificially add some duplication rows to the table. Now let's see the output again. Yeah, you can see we see some duplications now. From this C2, O2, C2, O2, from here, those are all duplications. 5 of them, we want to remove this. Okay, let's start working on that. Add one temp column called num to the table. The command is that when you want to add a column to a table or delete a column from a table, the command is called alter the table. And you give the table name by saying that we add a column called num, which is integer. By doing this, you can see if we added successfully. Yep, we do add the one column to the orders. So the first test is done. Then we want to assign a set number to be the row number output. Let's do this. And I want the row number over partition by. So order 1 has those 3 columns. We want to partition by those columns, right? So if they are the same, then we know they are duplicated. If all those 3 columns are the same, we know they are duplication. That's okay. And we need an order by. Order by, you can put something here. It's a required input, so we can put anything here. I will put order date here. Then I want to update because I want to set the num to we want to use the temp to replace the num. Update T0 by setting the num equal to the temp. So this is a command, so we can put the temp to the num. Let's see how it goes. Okay, looks like we are doing good. So now you see the num is actually no number here with temp. Now it's replaced by, we got all this. And then now we just have to delete the ones, which is another one, to deliver duplications. How to do this? Delete duplications. We want to use the command which is the delete from orders. And where num is greater than 1. So you can see that the SQL language is pretty like natural language. Okay, so as we see that 5 columns were dropped. So let's look at this again. Yep, we got it right. 9 original columns, which is here only number 1, but we don't really need the number 1 here. So we drop the temp column. How to do that? As we say, add a column, delete a column. We called alter table drop column. We could. Okay, command success. Let's look at the final output. Now we have that the num is dropped, so we got the original back. Is the we do the duplication. So this conclude the question. So let's review what we did. First, the most important is when you read the question that there is some information that's required to solve the problem, that's the customer data, and it's not, the information is not given. You have to point out and find a reasonable table that you think this information should be there. In our case, there's the order table, which should have the customer data because the customer created this order. Then here it's pretty, this is a straightforward. If we want to look at customer who purchased Kindle and Alexa, you can find all the users who purchased Kindle and all the users who purchased Alexa, and then you do a joint and get an intersection. Another way is that you do a self join, and it's either first item is Kindle, second item is Alexa, or first item is Alexa, second item is Kindle. Then both, then you get the user who purchased both of them. Okay, so this is the first question. Then the second question, found the purchase of the first purchase of the every customer. So in this, we need to introduce a window function, which is low num. Low num is very handy, and there's no parameter here. And you can use partition by, the order by. Partition by is just, as it means, just have a chunk. The row number will count every time when a new customer ID starts, and the order by is just order by. So with this, then you can set like num equals 1, so you get the first order. And they want the customer ID and the item ID, so you just do a simple joint to get the item ID. Delete duplicate rows from a table, which we did in the fourth step. First, add a num, and again we use row num, and all the table here is the key. So if they are all the same, we know there's a duplication. Then we know that if the num is greater than 2, greater or equal to 2, then we have to remove them. We'll delete from the table because they are duplications. Then we drop the temporary color. Okay. So Windows function is very important. It happened a lot in the interview. So let me do a quick example to show you most of the common window functions. So here I create again a small case called the user history. So let's get to see how this user history looks like. Just give you a feeling. So here from 1 to 7 are the records from user ID 1 coming from different dates. And purchase, maybe the dollars. The first time he purchased $11, $71, $61, $11, and then the user ID 2, they come 3 times on 3 different days, and the purchase 3, $1, $18, $13. So the color is the customer purchase $11, $12. Okay. So let's first look at the sum ordered by date. It will order by this day. So this is not a this is pretty straightforward. It just gives the accumulated sum. This is quite important actually. Okay. We don't have to, because user ID is not there. So when you see this, you can see how this window function does. Basically, it scans the whole table and do accumulation sum, like 11 first one, then the second one is 11 plus 11, that's 22, and 3 11, and then 33 plus 71 plus 1 plus 61 plus 11 plus 18, and you can see that just go up, go up, go up. So if you just use sum on the order by the day on the whole table, it will give you accumulated sum. This is pretty handy, but not very useful. Most of the time, people want to do a partition, right? So you know how every partition by user, then this order by user ID is more easy to see this way. So you can see that because it was confusing because the first item is here. It doesn't have a user. The first query doesn't have a user ID concept. It just look at the date. That's why the order looks kind of a bit weird, but it's fine. We just to make this easy, we just concentrate on the second one, user ID. Okay, so you can see this trunk is doing the same thing, that they kind of accumulate those numbers, and this is the final 186. For user 1, then the counter restart because you now partition by user ID, and the counter restart again because of user ID. Okay, this is the sum window function. Count is and average; those are all pretty similar ideas. So we review the sum partition by user ID, and count is just added 1, 2, 3, 4. It's very similar to row number. In this case, is same with row number. Then we have an average. Average is also accumulated average. So basically, it's the 11 divided by 1, 82 divided by 2, 143 divided by 3. So you get all those numbers. So those are the sum, count, and average. Those are all pretty handy, and they do something very similar. Row number, rank, and the dense rank. Those 3 comes together is a little bit also very handy. We see row numbers already. Now let's see how the others works. To make it clear, let's rank by, not by day, but by purchasing. In this case, just make the comparison for those 3. Then we don't want the day, we want to look at the purchase. So what row number do is that it was sorted by purchase amount, as we say. And again, because we have a partition by, so 1, 2, 3, they just treat them. The counter will restart every time when you use ID. When you have a tie, row number just give you 1, 2, 3, 4, 5, 6, 7. They don't care about the ties. If there's tie, they just randomly assign the number to that. And the rank instead, because those are all the same. They give you all 2, and then but it accumulated. Then when you jump to the next one, they give it 6 and 7, like the row number did. This rank is similar in the beginning, like rank 1, 2, but then when it jump, it give you the jump number. It give you 3 and 4. So those are the those are difference between row number. They just give you 1 to 7, 1 to n, and the rank they give you the types, and also when it moves, the rank jumps. But for dense rank, it doesn't really jump. It give you 1, and no matter how many of them are 2, the 1 comes following. Then we have 3 and 4. So those are the row number, rank, dense rank. They can be useful. Then next one is lead and lag. Lead, lag. Let's see how this works. Next, lead and the lag. Lead actually look at the previous function. For example, the lag. No, it's function by day. This the purchase. So we should look at the day to make it more sense. Lead is look at the next record. So because we want to look at the purchase column, and the lead is that I look at my next column and put it here. I look at the next column and put it here. Next, put it here. Next, put it here, here, here. And then now when I put it here, because 1 is one, this is the last record for 1. When I look at next, there's no. So I put a no here. And the lag is just the opposite. It look at the previous. When we look at this record, we look at the previous one, they put it here. And then when we look at this number, this record, the previous one, of course, it doesn't exist. So it's no. So yeah, lead and lag are just the opposite function. So just put move the column here. Move the first observation here, and this is move the next observation here. This is the difference between lag and the lag. So lag is basically they are quite useful, especially when the time that you want to calculate the time intervals. In this example, let's do this. So in this example, I use the lag function to bring the date here. So you can see that I use the lag day. So this one is put in here. This one is put in here. This one is put in here. Okay. And again, the first one, because the previous one doesn't exist, so it is not here. Then why this function is handy is that if I put the previous time here, then the time between the previous time and this widget is like a widget between time, like all the time since the last widget. So I can find the date time, the difference, our difference between the last widget and today's widget and the current widget. So this is giving me a time interval. So it says that for the second time the user 1 comes, the previous time was 719 hours ago, 23 hours ago, 23 hours ago, 1 hour ago. You can check that. Right, it's approximately 1 hour ago. Okay, so those are the quick introduction on the window functions. Those Windows functions are very handy and often asked during the interview. And I think I list all the Windows functions that are commonly used here.